All right, so we've seen a few KSP expressions and looked up a few values and tables in the book. Now, if you think back to our other discussions of equilibrium, when we calculated Kc values with our normal equilibria setups from just regular old equations, not just dissolving solids like we did last time, we did those KC expressions, and then we decided to change up things. We let things reach equilibrium, and then we changed the concentrations. And then we decided if it's shifting left or right. We're going to do the same kinds of things with KSP problems. And when we do that, we calculate a QSP. That's the solubility product quotient. So not at equilibrium, or suspected at not equilibrium. So we use QSP to determine if a solution of an insoluble salt, putting that in quotation marks because we know it's not entirely insoluble, of an insoluble salt at specific cation and anion concentrations. So for example, with our silver chloride that we looked at earlier, can I make a solution of silver chloride that is 1/1000th molar silver and 1/1000th molar chloride? We'd have to calculate QSP for that and compare that to KSP and decide. So to calculate QSP, it's the same setup as KSP. So write out the KSP expression. Now you plug in the concentrations that you're given. So plug in concentrations for all. So that we have a QSP value to look at. Then just like with KC, when we were doing those and calculating QC and comparing them, we have that comparison to make here. If QC is greater than KC, QSP is greater than KSP, when this situation happens, there are too many ions in solution. So when QSP is greater than KSP, we're going to shift left and precipitation occurs. That means you can't make a solution of those concentrations ion. There's too many ions present, some of it's going to precipitate. If QSP is less than KSP, then the solution can be made. It can be made, the solution will not precipitate. There aren't enough ions yet, so essentially it's going to shift right to get to equilibrium and dissolve more ions, which means there's no precipitation, obviously, that's occurring because more is dissolving. So this relationship is key. Whether QSP is greater than KSP, that means precipitation. If it's less than KSP, that means it will not precipitate. We can make that solution without a precipitate occurring. So we're ready to start some actual example problems for KSP. Set up the expression and plug in some numbers and actually get some calculating done. Bet you can't wait.